This study, entitled Tracking Offshore Movements of Common Terns Across the Southern New England Shelf, is funded by the Bureau of Ocean Energy Management and conducted in collaboration with the U.S. Fish and Wildlife Service Division of Migratory Birds and the University of Massachusetts Amherst. The objectives of the study are to evaluate digital VHF technology for tracking small-bodied birds offshore. Digital telemetry allows thousands of individuals to be uniquely and simultaneously monitored on a single frequency. Optimize the design of automated radio telemetry stations for detection range and directionality. Collect new information on the movements and distributions of common terns in our study area. And develop analytical techniques to model offshore flight paths from the automated radio telemetry data. The upper photo shows a common tern with a back-mounted 1-gram digital VHF transmitter called a NANOTAG. The transmitter has a burst rate interval of 5 seconds and an operational life of 4 months. The lower photo shows an automated radio telemetry station. The design consists of 6 9-element Yagi antennas arranged in a radial configuration atop a 12.2 meter mast. The antennas feed into an automated receiving unit that runs 24 hours per day on solar power. In 2014, we operated a total of 11 receiving stations that were configured to track the coastal versus offshore routes of birds across our study area. The locations of the receiving stations are shown on the map as red points, and the red lines show the direction and approximate ranges of the Yagi antenna beams to track terns in flight. The dashed blue lines show the approximate routes of 2 boat-based receiving stations on a federal research vessel and a passenger ferry, respectively. The yellow stars show the locations of 2 major tern colonies within our study area: Great Gull Island in Long Island Sound and Monomoy Island in Nantucket Sound. During the 2014 nesting period, we captured and nanotagged 51 adult common terns from Great Gull Island and 70 adult common terns from Monomoy Island. Overall, the telemetry array recorded 5 million detections of the 121 terns in our study, with an average tracking duration of 39 days. In addition, the array detected over 235 unique shorebirds, songbirds, and falcons that were captured and tagged by collaborators across the Atlantic seaboard and passed through our study area during migration. The radio telemetry stations in our array achieved detection ranges of 5 to 20 kilometers for terns flying at relatively low altitudes and up to 80 kilometers for shorebirds flying at migratory altitudes. This map shows an example of data collected by the common terns from Monomoy Island during the post-breeding period. The solid lines show detections by antenna beam, and the dashed line shows straight-line movements between the stations. A color ramp is used to represent the proportion of the tagged population that was detected on each antenna beam or straight-line movement path. Locations marked with asterisks were recorded during aerial telemetry surveys. The northernmost detection shows the location of a receiving station that was operated by a collaborator at a large tern colony in the Gulf of Maine, and detected terns from Monomoy during the post-breeding period. We are currently developing an analytical approach that combines a physical model for bird movement with the electrical characteristics of the receiving stations to more accurately predict the flight paths of birds from power received sequentially across the receiving array. Thanks for listening, and please feel free to contact the authors with any questions.